Welcome to the introductory video for the Idaho Numeracy Project. The goal of the Idaho Numeracy Project is to increase student achievement in mathematics by intentionally developing number sense through number knowledge and number strategy, and in turn increase teacher understanding about instructional practices that target and develop number sense and place value. The Numeracy Project is a free, optional, evidence-based resource for schools and districts to use to help students build a solid foundation in numeracy. The Idaho Numeracy Project is focused on developing students' understanding of numbers and their ability to use numbers to solve problems. Students may solve number problems by counting, adding, subtracting, multiplying, dividing, or any combinations of these operations. Students should develop strategies that support their use of these operations in real-world and mathematical problems. Consider what you notice or wonder about how this student thinks about the math shown here. Press pause until you are ready to move on. What did you notice? I might wonder how the student counted the chips in question 1. Did he count by ones, twos? How did they add 6 plus 2 in question 2? Did he count on? Was it a known fact? I noticed in question 3 that because the equation was already created, the student didn't actually have to problem solve. In question 4, I'm assuming the student counted each one of the cups because they are all crossed out, but I actually don't know what he did to get 30. Watch the following video, then press pause to ponder. What do we know about this student? What do we know about how she thinks? Okay, can you tell me how many blocks are there?
7.
Okay, hold out your hands. Okay, keep them separate. There's 3 blocks in that hand and 4 blocks in that hand, or 6 blocks in that hand. So how many blocks do you have altogether?
9.
9. So tell me what you did in your head there. Because I know you didn't count.
I know. 3
Okay.
plus 3. And so that's 6. But plus 3, there would be, so 3, 6, 9.
Gotcha. All right. So if I have 9 cards here, or counters here, and I have 7 counters here, how many counters do I have altogether?
16.
16? How did you figure that out?
Okay, so what I did is, I always know because 10 plus 7 would be 17, but since it's a 9, 9 plus 7 would be 16, because you would take 1 away from the 7 to make that a 10, which then 10 plus 6 is 16.
I could totally follow that. Good job. All right, let's try this one. Okay, there are 5 cups in a row, and there are 6 rows. So how many cups are there all together?
30.
How did the previous 2 assessments differ? It's important to recognize that how a student thinks about the numbers tells us a lot about how we should approach their interventions. The Idaho Numeracy Project is a free numeracy development resource adapted from the New Zealand Numeracy Project and the Georgia Department of Education, which introduces teachers and teacher leaders to the trajectory by which learners acquire a solid foundation in numeracy. The Idaho Numeracy Project is focused on developing students' understanding of numbers and their ability to use numbers to solve problems. Students may solve number problems by counting, adding, subtracting, multiplying, dividing, or any combination of these operations. Students should develop strategies that support their use of these operations in computation problems. As part of the Idaho Numeracy Project, students are engaged in learning ways to enjoy working with numbers presented in a variety of ways, making sense of numbers, how big they are, how they relate to other numbers, and how they may associate with a quantity, make sense of quantities, how much is in a set, Solve mathematical problems, whether real life or imaginary. Use mental math strategies to calculate their heads whenever possible, rather than using a calculator or pencil or paper. Show that they understand math using a variety of appropriate tools. Explain and record the strategies and methods they use to work out problems. Accept challenges and work at levels that stretch them. Work with others and by themselves. Discuss their mathematical reasoning with others and explain how they tackle mathematical problems. Students are encouraged to learn a wide variety of different strategies to solve problems. They are taught methods of choosing the most important strategy for each problem. The Idaho Numeracy Project uses a framework called the Number Framework, which was modified from the New Zealand Ministry of Education Numeracy Framework. This framework describes students' level of ability and ensures that the activities students are engaged in are suitable to meet their needs. At the core of numeracy development is the Number Framework. This framework was established to help teachers, parents, and students understand the requirements of the number knowledge and number strategies necessary to advance to higher levels of mathematical understanding. In the two main sections of the framework, the distinction is made between strategy and knowledge. The strategy section describes the mental processes students use to estimate answers and solve operational problems with numbers. The knowledge section describes key items of knowledge that students need to learn. It is important that students make progress in both sections of the framework. The strategy section of the framework consists of a sequence of global stages. Progress through these stages indicates an expansion in knowledge and in the range of strategies that students have available. The application of number knowledge and mental strategies is often described as number sense. Strongly developed number sense leads to algebraic thinking. The following table describes the key features of each strategy stage and of the number framework as identified by the GLOSS assessment. In the assessment phase, there are 2 interviews that are given to all the students 3 times per year and serve as a diagnostic, formative, and summative assessment. The assessments are applicable to KA students as well as identified students who are struggling with foundational numeracy in high school mathematics. The first is called the Global Strategy Stage Assessment, or GLOSS. This is a strategy screener. For example, is the student counting all or counting on? Is the student skip counting or decomposing the numbers? The GLOSS is a one-on-one student interview and is given verbally. The student attempts to solve the problem mentally, describing to the teacher how they got their answer. Within the assessment, there are 3 domains and 9 stages. The assessment questions are broken up into addition and subtraction, multiplication, division, and ratios and proportions. For each of these domains, there is a possibility of 9 stages. Once the GLOSS is scored, the student is given an individual knowledge assessment of number, the ICAN. If the student scores 0 to 3 stage, then the ICAN Part 1 is given. This is an individual verbal counting interview that assesses one knowledge domain that is number sequence and order, such as number recognition, number sequence, and forward and backward number word sequence. If the student scores a 4 to 8 stage on the GLOSS, then he or she is given the ICAN Part 2. This is a knowledge screener that assesses 4 domains: number sequence and order, fractions, place value, and basic facts. It is a written test that can be given to multiple students or the whole class at one time. The information gathered from these 2 assessments will help inform teaching strategies moving forward, such as small groups with differentiated lessons and interventions. Data from these assessments should be analyzed to determine the specific groups in the classroom and appropriate next steps to assist students as they progress along the continuum of numeracy development. After the teacher identifies the strategy and number knowledge stages for individual students, he or she can find the corresponding tasks or activities in the resource finder. Additional resources and information can be found in the Numeracy Development Project books as well. Student learning is greatest in classrooms where the tasks consistently encourage high-level student thinking and reasoning, and least in classrooms where the tasks are routinely procedural in nature. Taking early action may be key to helping students struggling with mathematics. The following 8 recommendations are designed to help teachers, principals, and administrators use response to intervention for the early detection, prevention, and support of students struggling with mathematics. Press pause until you are ready to go on. The Idaho Numeracy Project is aligned with the Idaho State Department of Education's goals to build a student-centered learning system that promotes relevant learning while allowing flexibility in both time and teaching methods, where student success is the only option.